Hi, my name is Alexander. In this video, we will explore Angular's change detection strategy using a project in which we will use the border color around each component to show whether the component is rendered or not. When the component is rendered, the border color will be red. When not, it will be white. The GitHub reference for the source code of the project is indicated in the video description. Angular change detection is a built-in framework feature that ensures the automatic synchronization between the data of the component and its HTML template view. Change detection works by detecting common browser events, like mouse clicks, HTTP requests, and other types of events, and deciding if the view of each component needs to be updated or not. There are two types of change detection, default and OnPush. With default change detection, Angular decides if the view needs to be updated by comparing all the template expression values before and after occurrence of an event for all components of the components tree. OnPush change detection optimizes performance by reducing the numbers of times Angular checks for updates in the component view. We also can use detach and reattach methods of the ChangeDetectorRef service to manually control a component's participation in the change detection cycle. This provides a way to optimize performance in specific scenarios. I have created a simple project where application component contains two child components, left one and right one. The left one component contains child component left2, and right one component contains child component right2. All components elements are located within HTML table object. Every time when component is rendered, its table border color is changed to red. Render component I use for the sake of brevity. Certainly I mean render components view. When application starts, all components are rendered and all tables have the border color red. When user clicks application button, the border click handler app button click changes the border color of all tables to white, and the border color is changed to red only for rendered components. Every component has a component's button. The button click handler just writes a log message in a console, component name button click, for example, left one button click, and has a log render function, which executes during rendering process and applies a red color to the table border of appropriate component. Now we use default change detection strategy. It means that any event triggers re-render of all components. That is why we always see red border of the tables by clicking any button. But we don't need to trigger render of all components by any browser event. For example, in our application, we don't need to render components which contain static images, like components left1 and left2. It can be solved by implementing OnPush change detection strategy. Let's apply OnPush change detection strategy to the left1 component. With OnPush, change detection never runs unless the view is dirty. Instead of checking component every time an event occurs, OnPush marks component as dirty when input properties change, an event is fired within the component, component is explicitly marked for checking. When a child component is marked as dirty, it will mark as dirty all its parent components. When change detection runs, it will call refresh view methods on the top view and on the child views which have been marked as dirty. Click application button. We remember that application button click changes the border color of all tables to white, and the border color is changed to red only for rendered component. We can see Angular didn't render component left1 and its child left2 component because we applied OnPush detection strategy to the left1 component, and an event happened outside the left1 component. When we press left1 button, It triggers rendering of left1 and left2 components. Apply OnPush chain detection strategy to left2 component. Click Application button and click Left1 button. This event triggers rendering of left1 component only, because the event happened outside the left2 component where we implemented OnPush change detection strategy. Click Application button and click Left2 button. Left2 component and its parent component are rendered. We remember that it is because when the child component is marked as dirty, it will mark as dirty all its parent components. For the components on the right side of the page, we added data transfer from a parent component write1 to a child component write2 using the input decorator. We transfer the string array parent data and observable items of type string array. In input field item, we can indicate item name. By pressing the button Add item to array, we add this item to a string array parent data and transfer this array to a child write2 component using the input decorator. By pressing the button Add item to observable array, we get value of observable as a string array current array, create a new string array new array with item added, create new observable with a string array new array, and transfer observable to a child component using the input decorator. By pressing the button Change Item, we change the second item in parent data array and transfer this array to a child component using input decorator. In write1 and write2 components, we use default change detection strategy. Add item to array. Child component render it with a new item. Add item to observable array. Child component render it with a new item. Change item. Child component render it with a changed item. Apply OnPush change detection strategy to the write1 component. Now events outside the write1 component don't trigger change detection on write1 and write2 components. Apply OnPush change detection strategy to write2 component. Now events outside write2 component don't trigger change detection on write2 component. Data transfer from a parent component write1 to a child component write2 using the input decorator does not trigger the change detection on the write2 component as well. It is because Angular's OnPush change detection strategy will not trigger change detection if input reference is not changed. This means that if we pass an array to a child component via input and then mutate this array by using push, pop, splice, then push change detection will not be triggered in the child component. To make it work, in addItem method, we have to create a new array with a new item added using spread operator. Now Add Item to Array button's click triggers change detection and array section is updated with a new item. The same is true for the observables. When use OnPush change detection strategy in Angular with input property that receives an observable, Angular will trigger change detection for the component based on the reference checks for input properties. If observable object reference is not changed, and this is our case, the change detection will not start on the child component write2. We can use mark4check, the method of the ChangeDetectorRef class, to make the component write2 dirty, ensuring that it will be included in the next change detection run that is triggered by Angular's zone or other mechanisms. We can use detach_change method as well, but for optimal performance, especially with OnPush change detection strategy, mark4check is generally preferred than detect changes because it avoids immediate, potentially unnecessary change detection runs. Mark4check method relies on Angular's regular change detection tick to eventually recheck the marked components. First, we have to inject the instance of ChangeDetectorRef class into the component's constructor. And we can use it in a subscription to the observable data to refresh write2 component when the observable emits a new value. Check that it works. It works. To make work change item buttons click, we can change the buttons click event handler so that it returns a new input array. Comment code and create another code. Change item button works now. The second item in the array is updated. Really, via the input decorator, the child component always receives the array with the new data or observable object with the new emitted values. But because an array or observable object has the same reference, Angular does not render a child component containing updated input object when we use OnPush change detection strategy. Let's demonstrate it. Command mark4check. Click Application button. Add new item to observable array. Really, the input data changed in the write2 component, but as we can see, the border around write2 component is white. It means that Angular didn't render write2 component. Change second item in array. With our updated code, it will render write2 component. As we can see, after rendering, write2 component shows updated second element in the array and added element mango in observable array. The most common and recommended way to handle observable inputs in OnPush components is to use the async pipe in components template. The async pipe automatically subscribes to the observable and, crucially, marks the component as dirty whenever the observable emits a new value. This dirty marking signals to Angular the component needs to be checked during the next change detection run, ensuring the view updates with the new data. The OnPush change detection strategy in Angular, when combined with async pipe, provides a powerful way to optimize rendering performance. Let's implement it. Remember that we commented the code change detection mark4check in the subscription to the observable data. Check that now write2 component with OnPush change detection strategy is not rendered by add item to observable array button click. The border around component write2 remains white. Add the code to write2 components view, where we use observable data with async pipe in the components template. Additional section async pipe added to the write2 components view. Child component write2 receives an observable from the parent component write1 using the input decorator. Because now the async pipe automatically subscribes to the observable and marks the component as dirty whenever the observable emits a new value, Angular renders write2 components during the next change detection run and updates the view with the new data. There could be special occasions where we do want to turn off change detection. For example, to improve performance in scenarios where frequent updates are not required, or when we want to change handle detection ourselves. In Angular, detach method of ChangeDetectorRef class is used to disable automatic change detection for a component and its subtree. This means Angular will no longer automatically check for changes in that component and its children during its regular change detection cycle. We would use detach method of ChangeDetectorRef service when you want to manually control when and how change detection happens for a specific part of your application. When detach method is called on a component, Angular will no longer automatically run change detection for that component and its subtree during the regular check detection cycle. That is why mark for changes method will not work as well. The component's view will not be updated unless change detection is explicitly triggered for it, typically using detect changes method of ChangeDetectorRef class. To re-enable automatic change detection for the components that was previously detached, we have to use reattach method. On component write1, we create writable Boolean signal detach flag that we will use to enable automatic check detection for a write2 component. Bind the signal to the checkbox so that the signal value depends on the checked state of the checkbox. Transfer signal detach flag to the child component write2. In Angular version 17 and later, transferring a signal from the parent component to a child component is achieved using input signals. This is a modern signal-based alternative to the traditional input decorator. Create input signal child detach flag of Boolean type on component write2. This creates a read-only signal that will receive its value from the parent component. In the parent write1 component's template, bind a signal to the child component's input signal using property binding. On child component write2, we have to create a function that automatically re-execute whenever its signal dependency, child detach flag, changes. In Angular, we can use effect function, which is typically created within the components or services constructor. This is because the effect function requires an injection context to operate correctly. Effect function in write2 component detaches its change detector from the main change detector tree when the child detach flag signal is set to true, and reattaches it when the child detach flag signal is set to false. Reload application. Click Application button. Click on Detach Component checkbox to turn off change detection. Click Application button. Add item manga. The buttons don't work. To make them work when child detach flag equal true, we have to explicitly use detect changes method of ChangeDetectorRef class. We can add it to a subscription and array section will be updated. When signal child detach flag contains Boolean value true, it means that change detection is turned off. We will use detect changes. Otherwise, it means that change detection is turned on, and we will use mark for check. Click on Detach Component checkbox to turn off change detection. Right 1 and right 2 button clicks do not render right 2 components view when change detection is turned off. Add item to array buttons click updates array items but doesn't render components view, so we don't see the changes. Change item buttons click changes array items but doesn't render components view, so we don't see the changes as well. Only add item to observable array renders components view because we added detect changes method in a subscription and we can see all updates. When async pipe expression is evaluated after rendering component by detect changes method, the async pipe section is not updated. By pressing add item to observable, we can render previous state of observable data in async pipe section as a side effect of using detect changes method in a subscription that we use for rendering items array. To make it work as expected, we have to re-enable automatic change detection by deselecting the detach component checkbox. Angular's change detection strategies are required to optimize performance and ensure the user interface remains synchronized with the application's data model. Angular offers different strategies and methods for optimizing change detection, particularly in performance-critical applications. Default and OnPush are change detection strategies, while detach and reattach are methods of ChangeDetectorRef class that provide manual control over change detection. That's all what I wanted to show you in this video. If you're enjoying this content and would like to see more and support my channel, please feel free to like this video and hit the subscribe button. Thank you for watching, have a good day, and bye.